Is suggesting the Earth may be on the verge of another mass extinction, similar to the one that killed the dinosaurs. It happened 5 times in the past 540 million years, but this time around, experts say we may be able to stop it. Michio Kaku is a physics professor at City University of New York and author of the new book, Physics of the Future, that we're going to be looking forward to the new book, of course. All right, Dr. Kaku, getting right to it. So which species would be most at risk?
Well, so far, if you analyze the last few hundred years of life on the Earth, human activity apparently has wiped out 1.4% of all plant and animal species, and it is 100 to 1,000 times faster than normal because of human population, development, pollution, overharvesting. And if you take a look at a zoo, many of the zoo animals that our children love, we may find them going extinct. The tiger, for example, may go extinct. Many of the familiar zoo animals, bears, and realize that 18,000 species are at risk.
And what about climate control? How does that, what role does it play?
Yeah, climate change is also involved in this thing. Independent of where climate change comes from, we see that the seasons are changing. Summers are getting longer. Winters are getting shorter on average. And we always say that the early bird catches the worm, but that assumes that the worm and the bird are synchronized. Many of these cycles, the natural cycles, are being thrown into disarray, meaning, for example, droughts in China going on right now, perhaps famine in certain areas. So we humans cannot be divorced from what's happening in the natural world.
We can't be divorced. Is there something we can do about it? I guess you said pollution is one thing we can do. But so what happens, Doctor, if there is not this sort of scientific pruning? Would the Earth be overrun with all sorts of creatures?
Well, evolution says survival of the fittest, and so far we humans are among the fittest. But we are also at the top of the food chain, the top of the pyramid, and it wouldn't take much to dislodge us from being at the top of the food chain.
So who could outrank us at that top of that food chain? You know what animals I need to look out for?
Well, in science fiction, of course, the insects take over. But look at something very simple. We are dependent on just a few crops, wheat, rice, and just a few crops, and if a blight were to wipe out these crops, then a huge chunk of humanity would starve to death because we're so dependent on just a few plants and animals for our existence.
So should we expand our menu, so to speak, or is there something else that the Earth provides that we should be looking at?
We should be wary of overharvesting. For example, overharvesting the oceans. We have drag nets, which in principle could drag the entire oceans. That's how efficient our technology is. Also, wheat production we have to worry about because water is the key to wheat production, and there are going to be perhaps water wars in the future.
And are you concerned about that water wars and that we may run out of water?
Well, there will always be water on the Earth. The question is the cost and what it would take to extract it, to desalinate it, to divert it, to irrigate. And so the cost of certain kinds of commodities could start to rise. So just because we're at the top of the food chain doesn't mean that we're invulnerable to what's happening outside where biodiversity is being threatened.
You mentioned, we have to go, but you mentioned insects could overrun the Earth.
Well, that's in science fiction.
Yeah, but the cockroaches, they never seem to go away, Doctor. We got to figure out a way to get rid of them. All right, Dr. Michio Kaku, thank you so much. And your new book we're looking out for is Physics of the Future.
There's a giant asteroid flying towards Earth. Detected by a Russian robotic telescope, it's one of the largest and most dangerous space rocks approaching our planet's orbit. RT's Murad Gaziev looks at the threat from the void.
Humanity's last experience with a large asteroid was painful. Almost 2 years ago, the Chelyabinsk meteor, traveling at 19 kilometers a second, exploded in the skies above Russia. The blast was dozens of times more powerful than an atomic bomb. But that meteor was only 20 or so meters in diameter, weighing about as much as the Eiffel Tower. This new asteroid is an entirely different story. It's 20 times bigger, the size of a village, weighing millions of times more. If this asteroid, for now called 2014 UR116, flew into our atmosphere, it wouldn't just burn up in the air and shatter windows. This would hit the planet's surface, potentially killing millions. But calm for now. It's not yet on a collision course with Earth. The danger is, as it passes near planets and the sun, gravity could alter its path. In fact, the Russian Space Agency, which detected UR116, has satellites watching just for such objects. And it's not only Russia. An American observatory a decade ago detected another similar asteroid. There was a big scare about that, if you remember. Apophis was named after the Egyptian god of evil, and asteroids its size hit Earth on average once in 80,000 years. NASA gave it a very real chance of impacting our planet, though that was later revised down. But the danger from asteroids is very real, and astronomers are increasingly keeping an eye out and thinking about what to do if they confirm a collision course, though don't expect anything quite as dramatic as Bruce Willis leading his team of misfits to save the world.
It's been almost 10 years since little Pluto was demoted from being a planet, but today scientists from the California Institute of Technology have announced that they finally have solid evidence for a planet X, a true ninth planet on the edge of our solar system.
It is believed to be far beyond the orbit of Pluto, roughly the size of Neptune, with a mass 10 times that of Earth.
There are things out there, little icy objects that are orbiting in a funny way, and nobody was quite sure why. It seemed like there might be something with gravity pulling on them, but nobody quite understood. And finally, these scientists that you talked about took a really hard look at it, did simulations, calculations, and they came up with the explanation: it probably is this giant planet.
I think I read somewhere it orbits the sun every 10,000 to 20,000 years.
Right.
Is that why no one has seen it to this point?
No, that's not why. It's because it's so dim. It's so far away that even though it's big, it's very, very dim, and it would be very tough to spot with a telescope.
I'm also fascinated at the idea that this planet could be so far out there and still our sun be the mass that is keeping it in the gravitational pull of our solar system.
Right, yeah, but no, it's true.
That's incredible. And so there was a thought at one point from scientists that when they thought that there was something beyond Pluto, that it might have been all the massive objects floating in the Kuiper Belt, but it's not.
Right, so all those objects are out there and they have a lot of mass, and originally the scientists said, look, a planet is such a crazy idea, maybe it's the Kuiper Belt itself that's pulling it on itself and making these orbits look funny.
And when we talk about the mass of this planet X, this ninth planet, being 10 times that of Earth, for those who are not scientists, what does that really mean, the mass of a planet versus Earth's mass?
Well, if you could put it on a scale, how much it would weigh.
Yeah.
I mean, that's really it. And so it's bigger, it's bulkier, it's got more heft, it's got more gravity. It's this huge elephant in the living room, except we didn't know it was there.
Mm-hmm.
You mentioned that scientists haven't seen it yet because of how far away it is and how dim it is.
Right.
Is there a way for them to get visual evidence?
Yes, so the biggest telescopes in the world can theoretically see this thing if they're looking in exactly the right place. And with the publication of this new paper today, they are now going to start to look in earnest.
How much further out there is this planet X than the rest of the planets in the solar system? I mean,
so Pluto we think of as the really out at the very edge, the very farthest thing that you could call a planet, even though we don't anymore. And
I'm still supporting Pluto's right to be a planet.
But this thing is 5 times further out than Pluto.
Fascinating. Is there any chance it's not a planet?
No, there's always. It's very foolish to say no chance because you just don't know what you don't know. But the odds are looking very, very good.
60 billion miles from the sun.
Yep.
Amazing stuff. Michael Lemonick, thank you so much. Fascinating stuff.
Great, thanks.
Good afternoon. My name is Dwayne Brown with the Office of Communications, and welcome to NASA headquarters. Today, NASA reveals near-Earth asteroid findings and implications for future research from the agency's Near-Earth Object Wide Field Infrared Survey Explorer, in short, NEOWISE. Today's information and graphics can be obtained on the web at www.nasa.gov/wise. We will have brief presentations from our presenters, then open it up for questions at our NASA centers and the phone bridge. Before we get started, let me introduce you to today's speakers. First up, Lindley Johnson, NEO Program Executive, NASA Headquarters, Washington. Amy Meinzer, NEOWISE Principal Investigator, NASA's Jet Propulsion Laboratory, Pasadena, California. Tim Sparr, Director, Minor Planet Center, Smithsonian Astrophysical Observatory, Cambridge, Massachusetts. And Lucy McFadden, Scientist, NASA's Goddard Space Flight Center in Greenbelt, Maryland. And with that, I'll toss it to Lindley to start us off.
Thanks, Dwayne. Thank you all for tuning in to hear about our progress with the Near-Earth Object Observation Program. We're here today to provide an update of our understanding of the near-Earth asteroid population and announce achievement of some significant goals in finding our nearest neighbors in the solar system. Over the past 12 years, our work to find near-Earth asteroids has largely been done by several ground-based observatory teams. But in 2010, NASA augmented those efforts by enhancement of the ground processing of the data being returned by the Wide Field Infrared Survey Explorer.
So one of the characteristics of NEOWISE is that it really was a fairly small telescope in a low Earth orbit. In fact, the telescope would kind of fit under your arm like this, so it's not particularly large. But by virtue of being in space and operating at infrared wavelengths, it's a very powerful telescope, and it turns out to be very good at finding asteroids and comets. Now, if you go to the first animation here, you can see a little representation of what WISE looks like going around the Earth. It's always pointing outward from the Earth, surveying the whole sky. And as the Earth goes around the Sun, this allows the telescope to very quickly and efficiently carry out a survey of the whole sky. And in fact, it was so fast we were able to survey the whole sky twice in infrared wavelengths in only 1 year. And you can see here a little representation of the difference between visible light and the infrared light that WISE was able to see. So this was a very efficient and effective way of surveying the sky. And the original purpose of the mission was actually to study cool stars in very distant galaxies, and it's doing a great job of that. However, it turns out to also be very good at detecting asteroids. This is because it's using infrared light.
First of all, I find it really exciting that scientists continue to find things in the solar system, bodies in orbit around the sun, and objects that are close to our backyard in the near-Earth space. I want to congratulate the team for your successes, and I know from experience that in order to conduct a survey and to locate and discover new bodies from spacecraft missions requires a lot of planning, a lot of ingenuity, huge amounts of computing power, and then hours and hours, months of discussions with colleagues and poring over the data to validate the results.
Thank you. I realize you're focusing on near-Earth asteroids today, but there's been so much talk about the potential for finding a planet X or some sort of large body through the WISE survey. Can you comment on any status on that sort of search, or maybe even reassure people that planet X isn't coming to get them next year?
Yes, this is Amy Meinzer. I'm happy to answer this one. Planet X is not coming to get us. But we are looking to see if there are any other bodies in the outer part of the solar system with the WISE data. This is a very natural project for WISE. And so we're still working on it right now. We've obviously just returned a huge amount of data from the telescope that's going to take us a long time to sort through. But the initial results are very promising. You may have seen earlier results where we've discovered a new class of very cool type of stars with WISE. But the search is still on, and we don't think that there's anything that's hazardous in the outer solar system. We think that this is just a sort of if there is something out there, it would be a large body in a roughly circular orbit.
Our next caller, Denise Chow from space.com. Denise.
So when you say the initial results are very promising, the initial results are very promising. Anything else you wanted to say on that point?
We've actually been able to confirm the discovery of 100 new objects that are these very cool stars called brown dwarfs. And so that's very similar to what people are interested in looking for. So we've actually found some of these that are relatively close to the Earth, but none of these are closer at this point than the nearest star to our solar system. So it's a good start, though.
Thank you.
The same thing, there'd be no necessity for science. The whole purpose of science is to see the difference between appearance and essence. In other words, the universe is crazy. In fact, it is crazier than we can even imagine. Who would have thought we would have quantum mechanics? Who would have thought we could have dead cats and live cats existing simultaneously? Who would have thought that you could be in many places at the same time? That's called craziness. It's also called modern physics.
Yeah, well, I think it's those big questions. Theoretical physicists seem to come up against those throughout their entire careers.
That's why I became a theoretical physicist. I wanted to bump up against those big questions.
Constantly. And so that's another question I was really interested in, is that I've heard that the majority of theoretical physicists are incredibly spiritual and have a great appreciation for the concept of consciousness and the soul and the universe and where it came from, because these are the questions that they're constantly asking. For yourself, what's your view on life, and where is it? What are we doing when we teleport life, if we ever get to that point?
Well, if I knew the answer to life, I would have an inside track up there.
Right. As would anybody, yeah.
But let me tell you how we physicists view things, right? For example, Einstein was asked the big question, is there a God? Is there a meaning to everything, right?
Right.
And here's how Einstein answered the question. He said, there really are two kinds of gods. We have to be very scientific. We have to define what you mean by God. If God is the God of intervention, the personal God, the God of prayer, the God that parts the waters, then he had a hard time believing in that. Would God listen to all our prayers for a bicycle for Christmas and smite the Philistines for me, please?
Right.
He didn't think so. However, he believed in the God of order, harmony, beauty, simplicity, and elegance, the God of Spinoza. That's the God that he believed in, because he thought the universe was so gorgeous. It didn't have to be that way. It could have been chaotic. It could have been ugly, messy. But here we have the fact that all the equations of physics can be placed on a simple sheet of paper.
Right.
Einstein's equation is only 1 inch long. And the quantum theory is about a yard long, but you can squeeze it onto a sheet of paper.
Right, with a small enough font.
Right. And with string theory, you could even put those two equations together. And string theory can be squeezed into an equation 1 inch long. And that equation, by the way, is my equation. That's string field theory. That's my contribution.
Right.
But we want to know, well, where did that equation come from? This is what Einstein asked. Did God have a choice? Was there any choice in building a universe? When he woke up in the morning, he would say, I'm going to create a universe. I'm going to be God today. What kind of universe would I create? This is how he created much of his theories. To make science interesting for people. First of all, we are born scientists. When we're born, we wonder what's out there. We begin to wonder about the sun, life, the stars, what makes the oceans, the weather. We're born scientists. And then something happens. When we hit the danger years of junior high school and high school, that's when it's literally crushed out of us.
Those are the worst.
Every little flower of curiosity, said Einstein, is crushed by society itself. Because we have to learn all these facts, figures, memorization. We think that memorization is science. And that's not true at all. My daughter had to take the Regents exam once, and she had to memorize all these facts and figures about minerals, crystals for a geology exam. Nowhere did I see the true driving force of geology, which is continental drift. That's the organizing principle for all of geology. And yet the exam was memorizing all the names of the crystals and the minerals. And then later she comes up to me and says, Daddy, why would anyone want to become a scientist? That was the most humiliating event in my entire life. I felt like taking that book and ripping it apart, because that exam was crushing curiosity right out of the next generation. And then we wonder, hey, how come people are not more interested in science? Duh.
Hi, I'm Kirsten Sanford, and I'm sitting here with Dr. Michio Kaku. Thank you for joining me today.
Glad to be here, Kirsten.
It's wonderful to have a physicist and a science educator such as yourself here to be able to speak with me. You are on a book tour right now. You've written a book, The Physics of the Impossible, which is really exciting and very interesting. What was it that kind of drew you? I mean, you write physics texts and you write popular books about physics.
Well, when I was a child, I had two childhood heroes. The first was Albert Einstein. When he died, everyone was talking about the death of the greatest scientist of the age. But everyone said that he didn't finish his masterpiece, the unified field theory, the theory of everything. I was a child. I was fascinated by this story. And I said to myself, I want to be part of that quest to finish what the greatest scientists of our age could not finish, the theory of everything. But I had a second hero, too. I used to watch Flash Gordon on TV. I was like glued to the TV set. But you know, after a while, you learn the facts of life. I didn't have blonde hair. I didn't have muscles.
Right.
And I said to myself, now wait a minute. It's the scientist that makes the series work. It's Dr. Zarkov. He invents the starship. He invents the ray guns. He invents the city in the sky, right?
Right.
Without Dr. Zarkov, there's no Flash Gordon. Without science, there's no science fiction.
Right.
So I said to myself, when I become a physicist, and I know exactly the boundary between the edge of physics and science fiction, then I'm going to write a book for somebody like me as a kid, wondering about invisibility and teleportation, starships and time travel. Well, now I'm a physicist, so I can write a book like this. And they told me, well, it's impossible that a book like that with physics in the title could hit the New York Times bestseller list.
And now?
And it happened. The impossible happened. It's number 12 on the New York Times bestseller list. So there are a lot of people out there just like me watching Star Wars and Star Trek and Terminator and then wondering, is it possible? Well, this book is for them.
Absolutely. And the question also, you say there's no science fiction without science, but that goes in the reverse also. Science fiction also drives science questions.
That's right. Take a look at Edwin Hubble. He's the greatest astronomer of the 20th century, discovered the expanding universe. But originally he was a lawyer. He was going to be a country lawyer, and that's it. But as a child, he read Jules Verne. And he had a romance of the stars. And he quit being a lawyer, went to graduate school at the University of Chicago, and he was in a rush, a real rush, because he was, much older. And he said, I'm going to make some big breakthroughs, and he made the biggest breakthrough of the 20th century, the expanding universe, which gives us the Big Bang.
Right, and it's led to so many other ideas about how the universe works, the concept of dark matter, dark energy, people looking at how far back time goes and what started everything out.
Gee, this is all the things I do for a living.
Yeah, I know.
That's my day job.
That sounds rough.
When we physicists look in outer space for alien life, we don't look for little green men. We look for type 1, type 2, and type 3 civilizations. A type 1 civilization has harnessed planetary power. They control earthquakes, the weather, volcanoes. They have cities on the ocean. Anything planetary, they control. That's type 1. A type 2 civilization is stellar. They've exhausted the power of a planet, and they get their energy directly from their mother star. They just don't get a suntan on a weekend. They use solar flares. They use the power of the sun itself to energize their huge machines. Eventually, they exhaust the power of a star, and they go galactic. They harness the power of billions of stars within a galaxy. Now, for example, Buck Rogers would correspond to a Type 1 civilization, a planetary civilization. Star Trek and the Federation of Planets, who have colonized a few star systems, would correspond to a Type 2 system. And the Empire of Star Wars would correspond to a Type 3 civilization. Now, what are we on this scale? We are Type 0. We don't even rate on this scale. We get our energy from, not from stars or galaxies, we get our energy from dead plants, oil and coal. But we can calculate when we will attain Type 1 status, in about 100 years. Now, every time I read the newspaper, I see evidence of this historic transition from Type 0 to Type 1. And I am privileged to be alive in the most important era in the history of the human race, the transition from Type 0 to Type 1. I read the newspaper and I see evidence of this everywhere. What is the European Union? The European Union has been formed to oppose NAFTA, that is, the United States, Canada, and Mexico. But why? Because we're seeing the beginnings of a Type 1 economy. Huge planetary trading blocks are the beginnings of a Type 1 economy. And what language will this Type 1 economy speak? Everywhere I go around the world, I find that the elites all speak English as a second language. In the future, the planet Earth will be like that. Everyone will speak their own native language, but on top of that, there will be a Type 1 language, probably English. There's also going to be a Type 1 culture and a Type 1 political system as well. You can go anywhere on the planet Earth and show people pictures of two individuals that are instantly recognizable by any human, Madonna and Arnold Schwarzenegger. In other words, we're talking about Hollywood movies. We're talking about rock and roll, rap music, blue jeans. That's going to be the planetary culture of the planet Earth. And what is the Internet? The Internet is the beginning of a Type 1 telephone system. That's all it is. And so this transition is perhaps the most important transition of all time. Some people don't want it. They fear this transition because this transition is to a planetary civilization tolerant of many cultures. These are the terrorists. In their gut, they fear this because they know they are witnessing the birth pangs of a beginning of a new planetary civilization, and the terrorists want nothing to do with it.
So as of May, we have the beginnings of the actual investigation into the predictions made by string theory.
Right. And then people ask the question, well, how come the Americans aren't doing this? How come the Americans have to knock on the door of the European Union? Because our machine was canceled in 1993.
Yeah, it got under construct. They started constructing it and
Congress gave us $1 billion to dig a hole. And they canceled the machine, gave us a second $1 billion to fill up the hole. $2 billion to dig up a hole and fill it
back up.
Right.
Right.
So why was it canceled? And why do I do this? Why do I speak before people? In the last day of hearings, one Congress would ask a physicist, quote, "Will we find God with your machine? If so, I will vote for it."
Oh my
The
goodness.
poor physicist didn't know what to say. So he said, we're going to find another subatomic particle. Well, you could hear all the jaws hit the floor.
Everyone, that's it?
And they said, $11 billion for another god-darn subatomic particle.
Right.
They canceled it the next day. So we physicists, in our minds, over and over and over again, have played that scene.
Yeah.
How should we have answered that question? How should we have justified an $11 billion atom smasher that is now being built in Europe?
Yeah.
I would have said something different. I would have said, God, by whatever signs or symbols you ascribe to the deity, this machine, the Super Collider, will take us as close as humanly possible to his or her greatest creation, Genesis. This is a Genesis machine.
Wow.
We're going to recreate Genesis chapter 1, verse 1 with this machine. But we didn't know how to answer it, so they canceled the machine. And
hindsight is always great, isn't it?
And now we physicists are knocking on the door of the European Union asking permission to get on their atom smasher.
But there are many European scientists who are also doing the same you know, asking the same questions, and so hopefully they're going to get into it.
Right. It's just that the focus is leaving the United States and it's going to Europe. So that's why.
People around the world may soon be able to experience a unique event. A comet should be bright enough to be seen with the naked eye later this month. An NHK Super High Vision video camera has captured footage of the one-time visitor from space. They took this footage of Comet Ison dragging its wispy tail across the night sky. It was discovered by Russian and other observation teams in September last year.
And some of this has been in and out of the news, and for really avid sky watchers, this is a big event coming in. It's Comet Ison, and Ison is the first time this comet has ever been in our solar system, so it's a really interesting event. And from now through Thanksgiving, this comet will be moving closer and closer toward the sun, and frankly, NASA astronomers don't know what happens when it gets to the sun and interacts with the sun's atmosphere. To give you an idea of what you're looking for, this was taken from the top of Mount Lemmon near Tucson, Arizona. Adam Block with the University of Arizona took this image, again using a small telescope to enhance the photography a little bit. But again, unbelievable images of this. And NASA, this is a NASA image of Ison as it moves toward the atmosphere of the sun. So it's really a special event, and not so much because it's visible. We've seen visible comets before, but it's because this is a brand new comet. It is come from about 4.5 billion years away from the depths of space. First visit to the solar system. So pretty fun. And you don't have to worry about, oh, I can't do it tonight, or oh, it's cloudy. From now through Thanksgiving, this should last. But the one thing NASA scientists don't know, Kim and Mark, is as it gets closer to the sun, what will it do? Will it break apart? Will it survive? Will it get brighter?
There's the ifs and buts, isn't there? Because we don't know whether it's going to burn up or break up, whatever the technical term is. Is there any precedent for it about, you know, how close a comet can get to the sun before you know whether it's going to break?
Well, comets are always very unpredictable, and frankly the sun is a bit unpredictable as well, so there may be solar flares.
I don't know if you can see these, Sarah. We've just got these new images in, actually, that are far more dramatic, of it shooting through the night sky with a huge trail behind it.